Now we talk about exponential random variables. So we say a random variable x is an exponential random variable if x has a probability density function which can be given as f of t is lambda times exponential of minus lambda t, where t is some positive real number and it is 0 otherwise. So otherwise means that if t is a negative real number, you take f of t as 0. So x is called the exponential random variable with parameter lambda. So the cumulative distribution function is given as from 0 to x lambda exponential of minus lambda t dt. So notice that we generally start writing here minus infinity. So instead of minus infinity I have written here 0 because from minus infinity to 0 this function takes value 0. So this otherwise means t is less than 0. So less than 0, that is between minus infinity and 0, this f of t is just 0. So that's why we are writing it from 0 to x. And then you just write f of t dt. So this is f of t dt. And if you integrate it, you get the distribution function as 1 minus exponential of minus lambda x, where x is some positive real number. So this is a valid density function right here, because you can integrate from minus infinity to infinity, which will be same as integrating from 0 to infinity, because less than 0 you have 0, and if you integrate it you get 1. Now exponential random variables are important examples, and they are important because they are used for modeling waiting times. So for example, consider x as an exponential random variable with some parameter lambda as 1 by 10, and x denotes the time taken by the post office to service a customer. So this time is taken in minutes. So probability that the service time will be more than 10 minutes, so probability x is greater than 10, is equal to 1 minus f of 10. So why f of 10? Because you know f of 10 is nothing but, by definition, is probability of x is less than equal to 10, and less than equal to 10 and probability of x greater than 10, these are complementary events. So either a number can be less than or equal to 10, or it can be greater than 10. So if you add these two, you will get 1. So it is true for any real number. Instead of 10 you could write any real number c. So probability of x less than equal to c plus probability of x greater than c will always be 1. So therefore you have probability of x greater than 10 is equal to 1 minus f of 10, and f of 10 you use this formula. So you can say f of 10 would be 1 minus exponential of minus lambda times 10. So now 1 and 1 would cancel out, so this is equal to 1 minus exponential of minus lambda times 10. So I've copied this right here. Now 1 and 1 cancels out, lambda is given to you as 1 by 10, so you are left with exponential of minus 1. So this you can compute. Probability that service time will be between 10 and 20 minutes. So that is random variable x lies between 10 and 20. This will be given as f of 20 minus f of 10. So f of 20 is probability that x is less than or equal to 20 minus probability that x is less than or equal to 10. So this will be exponential of, so now you can compute f of 20. So you put 20 here, and then lambda is 1 by 10, so you get, so you will get minus exponential of minus 2. So f of 20 comes right here and f of 10 comes right here, and then 1 and 1 cancel out. So yeah, you can plug it in and see, or let us write this down. So f of 20 would be 1 minus exponential of minus lambda times 20, and f of 10 is 1 minus exponential of minus lambda times 10. So f of 20 minus f of 10, now you can see 1 and 1 cancels out, and take lambda as 1 by 10, which is given to us. Plug it in. So this becomes exponential of minus 1. This becomes exponential of minus 2. Now, very important property of the exponential variable is that it is memoryless. So let us talk about this memoryless property. So basically it says that probability that x is greater than a plus b, given that x is greater than b, is equal to probability that x is greater than a, where a and b are real numbers. So in English it means is that, say you have an instrument. So the probability that the instrument will survive for next 10 days, considering that it has already survived for 10 days, is same as the probability that it will survive for next 10 days. That is, this conditioning on past 10 days or past 10 years does not have any bearing. So this conditioning on the past, so this b is the past, does not have any bearing. So let us see why for exponential random variable this past does not have any bearing. So basically, for example, in the post office problem, what it means to say is that the waiting time, this waiting time here, to be greater than some fixed number, say 10 minutes, 20 minutes or 30 minutes, is irrespective of what waiting time has been in the past. So let us see how it comes out to be. So since this is conditional probability, you write it as probability of x is greater than a plus b and x is greater than b divided by probability of x is greater than b. So we have to show this is equal to probability of x is greater than a. Now probability x is greater than c is given as exponential of minus lambda c. So this is again clear, because probability of x is greater than c, this is equal to 1 minus f of c. That is 1 minus probability that x is less than or equal to c. And you plug this in here, 1 and 1 cancels out. What you're left with is exponential of minus lambda c. So then you can see directly from this equation, probability that x is greater than b, this is nothing but exponential of minus lambda b. Probability that x is greater than a, this is nothing but exponential of minus lambda a. You multiply them together, you get exponential of minus lambda times a plus b. So you can see this is same, this is the right hand side. You have got exponential of minus lambda a plus b, and left hand side by definition instead of c you can replace with a plus b. You again get the same thing. So basically it says that there is no conditioning here. Notice that there is no conditioning here. There is absolutely no conditioning here. So therefore this conditioning here does not matter. So if you rewrite this equation, this will be probability of x is greater than a plus b and x is greater than b. This is precisely equal to probability of x is greater than a times probability of x is greater than b. So this is what we had to show, and this is equal to probability that from here x is greater than a plus b. So this conditioning does not matter, and that is the story of memoryless property. So basically how long the waiting time will be in the future will be independent of what the waiting time has been in the past.